matrices. So first we need to discuss about an elementary matrix. What is an elementary matrix? From the Wikipedia definition, an elementary matrix is a matrix which differs from the identity matrix by one single elementary row operation. What do we mean by this? Let's take the identity matrix first. 1 0 0 0 1 0 0 0 1. Now Gauss was a famous mathematician who told us about three basic elementary row operations. So three basic ERMs, elementary row operations. The first was multiplying a row by a scalar, as we saw during a scalar multiplication definition. Second elementary row operation is adding the multiple of one row to another. And the third is switching two rows. Now let's take an example of each of these elementary row operations and create an elementary matrix. So first, let me create the first matrix I, and let me say 1, and this, let me say, multiplying any row by a vector. Let me say, let me multiply it by a scalar, say 3. So let me multiply the first row by 3. So 3 0 0 0 1 0 0 0 3. This is the first elementary matrix. Let me make a second elementary matrix. So what I'll do here is I'll add 2 times the second row to the first row. So this will become 1 2 0 0 1 0 0 0 1. And the third type of elementary matrix, let me make this switching the first and let me switch the first and the second row. So this will become 1 0 0 0 1 0 and 0 0 1. Now let me tell you something quite amazing right here, which is, again, linear algebra is quite amazing. So let's say I have a matrix A with the elements as A11, A12, A13, A21, A31, A22, A23, A32, A33. Now notice what I'll do here. Observe. So let me say I1 matrix multiplication by A. So what will that be? 3 0 0 0 1 0. Oops, I think I made a mistake there. That is, again, 0 0 1 0 0 1 multiplied by A11, A12, A13, A21, A22, A23. This is 1, A31, A32, A33. So now let me multiply this. So 3 A11 will be the first element, 3A12 will be the second element, 3A13 will be the third element, A21 will be the second element, A22, A23, A31, A32, A33. What has happened here? Something quite amazing actually has happened here. Let's take a look at the first. So if you observe, what has happened is that by multiplying, actually we should be a little more prudent and say by pre-multiplying A with I1, which is an elementary row matrix, we have multiplied a row of A by a scalar. So this is quite amazing. We have actually multiplied A, the first row of A, by a scalar 3 by multiplying it with I1. So let me call this observation 1. Now let's compute I2A. What was I2? I2 was, if we just take a sneak peek, I2 was 1 2 0 0 1 0 0 0 1. And A again is A11 and so on. So let me just write it only. A22, A23, A13, A12, A32, A33, and A31. Now if I multiply this, let's see what happens. So 1 A11 plus A21. This is A11 plus A21. 2 times A21 actually, because 2 will be multiplied by 2. This is A12 plus 2 times A22, second element. Third element will be A13 plus 2 times A23. And you can obviously compute the others. So notice again the first row here. What has happened? What have we done here? What we have done here is actually of great significance in mathematics. By pre-multiplying A with I2, which is again an elementary row matrix in which we multiply 2 to the second row and added it to the first row, we have done the second elementary row operation. And you can similarly verify for the third. When you pre-multiply I3 with A, this is equivalent to changing two rows 1 and 2 of A. Interchanging two rows 1 and 2 of A. So this is very important actually. This is of great significance when we'll study the next topic, that is Gauss-Jordan elimination, and Gauss's all the methods that he gave for computing matrices and all that stuff. So these observations are very important about elementary row matrices, and keep them in mind. By multiplying a certain matrix A by a certain elementary matrix, let's say E, we get a row operation. We accomplish a row operation. So this is very important.